Hello everyone, we'll start the module 3 of data structure using C++. So the first concept in the module 3 is queue. So before going to the queue, we need to understand about the stack. So already we have learned about the stack in the module 2, that is last in first out. The element that is inserted at the last will be deleted at the first. Then what is a queue? A queue is nothing but it is a linear list in which insertion takes place at one end and deletion takes place at the different end. In the sense, first in, first out. The element that is inserted at the first will be deleted first. The example is the people standing in cinema theater for the tickets. The person who will come first will get the ticket first. So that is the meaning of the queue. So the end at which the new elements are added is called rear end or back end. The element that is deleted from the other end is called as front end. You can see there below example, we have got A, B, C, three elements. A is at the front end, C is at the back end. In the sense that end, back end is nothing but insertion end, front end is nothing but deletion end. Then we'll see the abstract data type. So in this abstract data type of the queue, instances are nothing but ordered list of elements. One end is called front, other end is back. What are the operations present in this queue? We have got empty, that is nothing but which returns the queue is empty or not. And size returns the number of elements in the queue. Front returns the front element of the queue. Back returns the back element of the queue. Pop is nothing but which is used to delete the element from the queue. Push of X is nothing but add the element X at the back of the queue. Now we'll see the abstract class. So we already know what is the abstract class. The class which contains the virtual function is nothing but abstract class, and the virtual functions are initialized to 0. So that class we call it as a abstract class. Then you can see there we have got a destructor, then empty function, size function, front, back, pop and push. So now we'll see the array representation. So the storing the elements of the queue by using the array is nothing but array representation. Here the queue elements are mapped into an array queue using the equation location of I equal to I. So what is this equation? Element I of the queue is stored in the queue of I location. So let array length be the length of the queue or capacity of the queue, and queue front and queue back be the front and back elements of the queue. Now whenever we are using the equation 1, then the queue front is equal to 0 and queue back equal to -1 initially. And below diagram you can see the some of the examples of the queues. And whenever we are using the equation 1, we can see how the operations are performed. You can see there we have got three elements A, B, C which are stored in 0, 1 and 2. Then whenever we are deleting an element from the front end, we can see there in the diagram B, we have deleted A, but the locations 1 and 2 are shifted to the left. Now we have got only two locations, that is 0 and 1. C has came from location 2 to 1 and B has changed it to the location from 1 to 0. In the sense shifting. If we delete the element from the queue, the locations are also shifted. Then whenever you are inserting an element by using the equation 1, we need to increase the location by 1. So this is about using equation 1. We have got one more equation there. We can see there equation 2, location of I equal to location of front element plus I. Here by using this equation, no need to shift the element from right to left whenever we are deleting. Just move the location to the front. We can see there in the below diagram, we have got again three elements A, B, C. They are stored in 0, 1 and 2 location. And whenever we are popped A element, no need to shift the element. But B remains in the same position, C also remains in the same position. Clear? There is no need to shift. So whenever you want to insert, again there is nothing change, just increase the location by 1. So this is about the queue. So in the next class we'll continue.